Good afternoon. I'm Dave Tegeder, and thanks for inviting me to share with you one of the newest and most exciting developments from the U.S. soybean industry, high oleic soybean oil and its application in food service and food manufacturing. With its significantly different fatty acid profile and improved heat and oxidative stability, we're really talking about a new premium soybean oil for the food industry. I'll try and not make this too much of a chemistry class, but in order to understand the benefits of high oleic soy, you first need to understand what makes it have superior functional properties. Commodity, or regular soybean oil, is comprised primarily of polyunsaturated fats. Poly means multiple, and it's these multiple or many double bonds that makes regular soybean oil less stable. When an oil is exposed to heat, air, moisture, or reactive metals, these double bonds start to break apart, and that is how an oil degrades and becomes rancid. In the past, refiners used to partially hydrogenate soy oil to improve its stability and functionality. But that created trans fats, which were linked to coronary heart disease. So the food industry rapidly moved away from partially hydrogenated oils in favor of more stable, zero trans fats liquid oils. This was initially a huge dilemma for the US soybean industry, since nearly 50% of the soybean oil used in food was in the form of partially hydrogenated products. Fortunately, with advances in plant breeding technologies, the US soybean industry had been developing new high oleic soybean traits that changed the fatty acid profile inside the soybean seed. As you can see, we now have an oil with 75% oleic or monounsaturated fat, with less than 10% residing in the polyunsaturates and a 20% reduction in total saturated fats. So why is this important? When we look at the relative rate of oxidation in fatty acids compared to oleic or monounsaturated fat, linoleic acid is 40 times faster at oxidizing. Linolenic acid is 98 times faster at going rancid. This is why commodity soybean oil typically had to be hydrogenated in order to have the stability required by the food industry. With most of high oleic soy oil's profile now residing as the more stable monounsaturated fat, having only one double bond, this provides significantly improved heat and oxidative stability over commodity soy and other vegetable oils. It's also important to note that all of the changes made within the soybean were only to the oil's fatty acid profile. When you analyze the protein from high oleic soybeans, it's nutritionally identical to regular soybean meal when fed to livestock. I'd also like to point out that when we compare high oleic soy to olive oil, you can see the fatty acid profiles are almost identical, with the exception of high oleic soy now having less saturated fats than olive. And while most of my comments are on Corteva Agriscience's Plenish high oleic soy trait, which is the most commercially grown at this time, there are other high oleic soybean varieties available for potential production. Bayer Crop Science's Vistiv Gold trait is lower in total saturates, but also slightly lower in its oleic content and therefore slightly less stable. Missouri Soy's high oleic soybean trait, called Soyleic, is a non-GMO, but it also experiences a wider fluctuation within its fatty acid profile. So the US soy industry has high oleic varieties suited to whichever attributes your customers value the most. The fatty acid profiles listed here represent the seed trait has shown to produce looking at its whole soybean analysis. The final contracted oil profile may vary slightly from the above due to small amounts of commingling with regular soybeans and/or oil during the extraction and refining processes. It's also possible that the geographic location, or where the crop is actually grown, may have a minor impact on the resulting fatty acid profile. Typically, areas with a shorter growing season might have a slight reduction in the final oil's oleic content. So what are the benefits of high oleic soy? Well, for starters, it's a healthier oil with 0 grams of trans fats per serving, 20% less saturated fats, and high in heart-healthy monounsaturated fat, similar to that found in olive oil. It also has a 2 to 3 times longer fry life than regular soy, which translates into fewer oil changes, annual oil cost savings, and less packaging material to dispose of afterwards. A cleaner, lighter flavor. Because the oil is so stable, there's less of a residual oil flavor, which allows the inherent flavor of the food to be tasted, not that of the oil being used. A higher smoke point. We typically see approximately 10 degrees higher than that of commodity soy, high oleic canola, or even high oleic sunflower oils. Easier cleaning. Reduced polymer formation on cooking surfaces leads to less gummy buildup on fryers and equipment. For packaged foods, we see a 3 times longer shelf life when compared to conventional soybean oil. And a trend we are seeing today in the US food market is consumers wanting products made with simpler, more easily understood ingredient labels and having no artificial preservatives. High oleic soybean oil's excellent oxidative stability allows a food manufacturer to not have to use synthetic antioxidants in order to achieve the needed shelf life for its finished products. And high oleic soy offers a better oxidative stability index, which I'll discuss in detail next. The oxidative stability index, commonly referred to as the OSI test, is used to compare an oil's relative resistance to oxidation. In this test, just remember, the higher the number of hours, the more stable the oil. As you can see from the bottom of the chart, most commodity oils, such as corn, canola, and regular soy, go for only about 6 to 11 hours. High oleic canola and sunflower oils top out in the mid to upper teens. Palm olein ranges in the low to mid 20s, and yet high oleic soy goes greater than 25 hours and typically reaches 30 hours or more. You might wonder how high oleic soy can have more stability than high oleic sunflower oil, which has an even higher oleic acid content. Well, it's the combination of a high oleic content and the high amount of naturally occurring antioxidants, which are the tocopherols found in soybean oil, that result in high oleic soy's superior stability. High oleic soy, just like conventional soy, has the highest concentration of these important antioxidants. In addition, they also have the highest amount of delta and gamma tocopherols that offer better protection to an oil than the less stable alpha and beta varieties. We're all familiar with real-world consequences of oil oxidation in the food industry, from cleaning and maintenance issues to excessive foaming in fryers, and of course, the resulting rancid flavors and off odors. When we look at high oleic soy's performance in food service, one test that is usually performed is a fry test comparing different oils. While there is no global standard for when to change your fryer's oil, one of the best standardized methods is that used by the European Union, where they monitor the formation of total polar materials, or TPM. The EU has set a maximum 25% TPM content as the endpoint for a fry oil, and of course, the lower the percent TPM, the better. As you can see in this graph, high oleic soy achieves a 2 to 3 times longer fry life than conventional soy. This translates directly into fewer oil changes and lower annual costs associated with the oil. You're also providing your customers with a better tasting and less greasy foods due to the reduced oxidation, and there's notably reduced foaming in the fryers. I mentioned earlier that the reduced polymer buildup is a major benefit for high oleic soy. Very simply, a lower amount of polyunsaturates equates to less polymer formation. At the bottom of this slide, you'll see side-by-side photos of deep fryers that have fried the same number French fry batches, and the results are pretty obvious and speak for themselves. If any of you have ever been around fryers or spilled oil on your stove, you know how hard it is to remove this greasy buildup. High oleic soy results in improved facility cleanliness, decreased equipment maintenance, and less greasy film buildup on surfaces in the surrounding areas. The images and values on the right shows the various viscosities when the oils listed were heated at the same temperature and for the same amount of time. Results ranged from the less stable oils on the bottom of the chart becoming completely solid, advancing all the way up to high oleic soy, which stayed fluid and had the lowest viscosity results in the test. High oleic soy's neutral flavor and exceptional stability also provides an excellent opportunity to blend with other oils. For food companies that may prefer a certain oil's flavor in their finished products, they can still improve its stability by blending it with high oleic soy. This graph shows increased OSI scores for corn, cottonseed, and peanut oils when blended with high oleic soy, especially when the blend ratio reaches 50% or greater. When we look at how high oleic soybean oil can be used in food service, the applications are almost unlimited. Certainly, it's an excellent frying oil or pan grill oil for sauteing, or can be used as a pan spray for anti-sticking or as a popcorn oil. It can also be used to make salad dressings, sauces, mayonnaise, in addition to making blends with olive and other oils. We also see it being used for donut frying, along with cake and icing shortenings, and even shows a potential application in the retail bottle market, where its desirable nutritional profile and clean, neutral flavor offers consumers direct benefits. Here are just a few examples of the high oleic products that are currently being sold into the U.S. food service market. Quite a few of the frying oil offerings are in fact blends of high oleic soy with regular commodity soybean oil. This provides a more economical offering for customers who are more price sensitive, but also want improved performance in their oil. Now, turning to food manufacturing, when we look at high oleic soybean oil's performance in food processing, we can do so by testing each oil's oxidative stability and resulting shelf lives using a Schall oven test. In this test, each oil is heated in an open container at the same temperature for a given number of days, and then measuring the resulting peroxide value, which shows how far an oil has oxidized. In this case, the lower the number, the better an oil stability. 1 day in the oven approximates 1 month of shelf life, so a 12-day Schall oven test is approximately the results you'd see from a 1-year shelf study. As you can see on this graph, high oleic soy demonstrated the lowest formation of peroxide value compared to any other oil tested. And that translates directly into significantly better shelf life for processed food products. One of the most challenging reformulations was in the baking industry, where they need the functionality of a solid shortening for specific product applications. A liquid oil simply cannot deliver the flakiness desired in a baked good or creaminess in a cake frosting. By using an interesterification process that combines a liquid oil with a solid fraction at the molecular level, refiners have now been able to produce shortenings formulated with high oleic soybean oil that are truly drop-in replacements for the old partially hydrogenated products, in addition to providing a more desirable melt curve and the resulting improved mouthfeel when compared to palm-based shortenings that tended to have a waxier mouthfeel. High oleic soy shortenings are also able to achieve the same amount of required solids, but with 15 to 20% less saturated fat content and without compromising functionality. Applications for high oleic soy oil in food processing range from industrial frying, such as par frying frozen potatoes, chicken and seafood products, to frying salty snacks such as potato chips, or as a coating oil for extruded snack products. It can also be used in baked goods as a spray oil for crackers or in cookie shortenings, along with frostings, icings, and even donut frying oils. In commercial bakeries, it's being used as a pan release spray, with the added benefit of less polymerization on the bread pans. And in consumer retail market, it's being used to produce non-dairy coffee creamers. Current suppliers include most of the top U.S. soy processing companies, including ADM, AGP, Bunge, CHS, and Purdue Agribusiness, in addition to the seed development companies. High oleic soybean varieties are being grown in the major soybean producing states across the Midwest and over to the Mid-Atlantic region, and the acres continue to grow with the oil's increased demand. The United Soybean Board's goal is to have 16 million acres, or about 20% of the total U.S. soybean crop, grown as high oleic varieties by 2028. And there is the potential for U.S. supply chain opportunities for either semi or fully refined oil or whole high oleic soybean exports to service international customers. Your local USEC representative can help you with contacting the appropriate high oleic soy suppliers for your specific needs. If you are considering high oleic soy, it's important to understand that forward contracting is needed to help assure availability for your supply chain needs. High Oleic soy is still in early stages of commercialization relative to commodity soy or other oilseeds. Today's increasing demand for high oleic soybean oil has resulted in limited amounts of uncommitted supplies available for immediate market sales. Rest assured, suppliers will certainly be able to supply you with samples and the amounts sufficient for lab or pilot plant testing, but large commercial quantities will definitely need to be forward contracted. By the end of this summer, U.S. suppliers will be finalizing the amount of high oleic soy oil that they will have available for next year's crop. That oil will be for sale beginning in the fourth quarter of 2021 and then on into calendar 2022. If you're seriously considering purchasing high oleic soy for 2022 usage, it's important you start having those discussions with U.S. suppliers by the end of this August. It's also important that farmers do not commingle high oleic soybeans with their commodity soybeans, either in the field or in their on-farm storage. Commingling would simply dilute the crop's purity and diminish the resulting oil stability. To prevent this, high oleic soybeans are grown in closed-loop, identity-preserved supply chains. Individual farmers contract directly with soy processors or exporters for a certain amount of high oleic soy production. There are also specific quality control requirements that farmers must meet when they deliver the high oleic soybeans in order to guarantee the crop's purity. An added advantage is that these programs allow for great sustainability and traceability stories for end users. Today's consumers often want to know whether the food they eat was produced in a sustainable manner. This is easily satisfied since high oleic soybeans are also included in the U.S. soybean industry's Sustainable Assurance Protocol. U.S. soybean growers are committed to being stewards of the land they farm. This includes a variety of sustainable practices to reduce their overall land use, soil erosion, energy use, and total greenhouse gas emissions, along with improving water use efficiency. These practices allow for independently audited programs that verify U.S. soybeans are produced in the most sustainable manner. The improved frying and shelf life benefits of high oleic soybean oil allows for even better sustainability advantage over other competitive oils when you calculate in total reduced oil used in fryers, less packaging, and the reduced amount of food discarded before it had gone bad. Many consumers also want to know where ingredients originate from and who's growing them. The closed-loop, identity-preserved supply chains and production contracts used with individual farmers allows high oleic soy suppliers to offer a very compelling traceability story for end users. So, to recap, here are the primary opportunities to consider with high oleic soybean oil. With an extremely high oxidative stability, it's an excellent oil choice when considering the packaged shelf life challenges in warmer climates. It provides a 2 to 3 times longer fry life over commodity soybean oil. With fewer oil changes, this saves money on your annual oil cost. With less residue on your fryers and equipment, there's less labor costs and associated downtime for cleaning, along with extending the life of your equipment. It provides a very neutral and clean flavor that makes for attractive blending opportunities with other oils and allows you to optimize functionality, flavor profile, and cost for the resulting blended oils. As a new product, high oleic soy provides a great marketing opportunity to expand product line offerings and bring your customers more healthful, sustainable, and traceable foods that also taste great. And equally, if not more important than all of the above, U.S.-grown high oleic soybean oil is the most affordable high oleic oil available from the North American market. You can find additional high oleic soy information, along with functionality results, case studies, and end-user testimonials on the www.qualisoy.com website. We have also developed a U.S. high oleic sourcing guide that is now available from your local USEC representative. And finally, I've provided a QR code that you can scan, if you so desire, to directly import my vCard contact information into your smartphone. And with that, I conclude my presentation. Thank you for your time, and I look forward to answering any questions during the panel discussion.